So our talk this evening here is Autonomous Vehicles, a 2026 Industry Perspective, and it's presented by Brendan Fleming. And Brendan is Business Development Director at Anduril, a civil engineer who graduated from what was University College Galway and is now the University of Galway. Brendan developed extensive experience of the rail sector in Germany and the UK before joining Dublin-based Class, which is now part of Anduril Industries, to develop communications and edge computing solutions for the transport and automotive sectors. So I'd like to welcome Brendan to the stage and look forward to his talk.
Thank you very much, Don. It's an absolute pleasure to be here tonight at the Institute of Civil Engineers, presenting to Engineers Ireland GB region. As Don rightly said, I graduated from UCG back in '93. I am a civil engineer, so I'm entitled to be here, I believe. I worked in the rail industry for many years, 6 years in Germany and 17 in the UK, before changing careers slightly. The time I had done in Germany stood me to stead when somebody in the tech industry, a mutual friend of myself and Don's, was looking for some assistance with a project they had ongoing with Deutsche Bahn, German Rail, my old employer. So I jumped in and helped them out and helped them out and helped them out a little bit more, and eventually said, come and work for us. So that was 10 years ago this year. I knew nothing about technology, hardware, anything like that before that point, but certainly the last 10 years has been it's been an adventure, to say the least. So back to the subject at hand tonight. What does autonomous mean? So definition straight off of Google was having autonomy not subject to control from outside, and to be independent. So free thinking, independent, whatever. So apply that to autonomous driving then, or autonomous vehicles. What does it mean? It's pretty much the same thing. It's acting independently and not subject to controls from outside or inside the vehicle, as it were. But more specifically, humor aside, it's the vehicle is capable of sensing their environment, navigating and operating without human intervention, which is an interesting one, and we'll get onto that in a lot more detail during this presentation. And that, how do you achieve that? You use technologies like sensors for the most part, previously known mapping, and data about your surroundings, and then overlay some AI on top of that as well to give you your self-driving solution. So just running through, apologies if you were here, I think 5 years ago, did we say, Don, that I gave my initial talk on the autonomous driving sector. And there's a little bit of repetition here, however, I'll just run through it. Right, SAE, Society of Automobile Engineers or Engineering. So SAE are the ones that set the standards in the automotive sector about what's acceptable and what isn't. So, you know, it's a bit like Euro norms or British standards, anything like that. In the whole vehicle sector, it's SAE, they say what goes and doesn't go. So they've predetermined these levels of autonomous driving. Level 0, the one that we know and love from the 1970s and 80s, with no automation whatsoever. Driver is completely in control of the vehicle that they're operating. Then as you work your way across left to right on this slide, you'll see level 1 and level 2. Now, a lot of cars, anyone that's kind of bought a car in the last definitely 5 years, possibly 10 years, will have some degree of level 1 and or level 2 in their car. That can be things, I'll get onto what they are in more detail on the next slide, of course. And then, so there's a divide kind of down between level 2 and level 3 there. So level 3, you'll see, is conditional automation. The vehicle can control most driving tasks. Now, it still has to have a driver behind the wheel. The driver has to be eyes on and not necessarily hands on, but just be available to jump in if they're required. Level 4, then, it's even more so. It's even more of the conditions for self-driving are met. But it won't be able to do some things. It might not be able to do fog. It might not be able to do snow or ice, where things like traction or control of the vehicle is unpredicted by the computers that run the vehicle themselves. And then on the right-hand side there, level 5, and you can see our little dummy there has a book out, because that's what people do when the car is driving itself. and they're completely unaware of their surroundings. They'll just simply get to their destination and step out of the car. So those are the levels of autonomous driving. I will be cross-referencing back to this slide on occasion during this talk, and I think it'll certainly raise some questions towards the end as well. So advanced driver assistance systems, ADAS, if you like. So what have we currently got in our cars? A lot of you, most of you will have seen these little symbols that you can see on the screen at the moment. So lane departure, that depending on who made your car, that annoying beep or that annoying jerk of the steering wheel back into the lane. So it's a beep at best, and it grabs the control off you if you leave your lane at worst. Blind spot assistance, you can see it there in the mirror to say that there's a vehicle in your blind spot, so don't do anything stupid or rash now. And then the bane of my life as a Volkswagen Group driver, the collision assist. The one that is extremely paranoid and thinks that you don't know where the brake pedal is and that you're going to hit that obstacle in front of you. And generally you don't. I won't say always, but generally you don't, right? So we're kind of familiar with those. Adaptive cruise. A lot of new cars have it nowadays, unless you buy a BMW and you still have to pay extra for it. But anyway, so adaptive cruise, what does that do? Well, as it says, you set a speed there, you set a distance, probably not as shown in the picture here, but you set a distance that you want to be behind the car in front of you. And it'll keep you that distance and that speed away from the car in front of you. If that car in front brakes, your brakes go on as well. If that car speeds up again, you speed up again to the prescribed limit, all that kind of stuff. A lot of the ones nowadays as well, they'll keep you in the lane. So it's adaptive cruise, and it'll steer between the white lines for you as well. So we'll have a little pop quiz in a minute. Actually, I'll do it now. What autonomous driving level would that situation be if it's accelerating, braking for you, and keeping you in the lane? Where would it fall between 0 and 5? It is 2, but a lot of people say 3. A lot, because if I just whiz back to the automated the levels of autonomous driving for a second, you can see that the vehicle can control most tasks. Well, the vehicle in that instance can't actually navigate its way around the obstacle. It can't overtake it. It can keep up with the car in front, and it's using that as a reference. It can keep between the white lines or the broken lines, and it's using those as a reference. But can it control most driving tasks? The answer there has to be no. So according to the SAE, it's very firmly in level 2 in that situation. So just going back to that slide then. Yeah, as we said, level 2. So technology, how does an autonomous vehicle work? And I guess looking at the front of the vehicle, you can see a radar sensor on the front there. That's the component used for the adaptive cruise control, the one that keeps you a set distance from the car in front of you. Nice and easy. Combine that then with a lot of other radars positioned at the extremes of the vehicle to detect obstacles around you. Cameras mounted on the vehicle as well, which will be used effectively with AI to determine where obstacles are, to identify things, to say that's a child on a bicycle, that's a HGV. And we'll talk about the limitations of those systems as well. And then on the top of the car there, you will see probably the most important component for self-driving, the LiDAR. Is everyone in the room familiar with what LiDAR is and what it does? I know it's a common application in civil engineering. Even when I'm going to say finished my civil engineering career 10 years ago, we used to use LiDAR on the railway as a means of surveying the corridor of the railway to ensure safe distances and to determine topographically. So it was an instant topographic survey, if you like. So all of those things combined, they all go into a central unit there marked as an IMU on the top of the car. And that central processor processes the data and determines where you can drive, where you can't, what the obstacles are. The obstacles are constantly moving. The LiDAR is spinning around. You'll have probably seen them on some cars equipped with LiDAR yourself. And you think, what's that moving thing on the top of the car? That's the LiDAR. And it is the key part there. So just kind of geographically, and you can, or not geographically, sorry, just as a bit of a 3D view of those sensors and what they do and how effective they are, I guess. So you can see ultrasonic sensors on the car. They're very, very short distance. Again, a lot of you will have them on your car to help you with parking, whatever else. So they're very short distance. You can see radar then slightly longer distance, and there's millimeter wave radio marked on the millimeter wave radar marked on the front of this car as well, and that's slightly longer distance. That's up to 200 meters. And then the LiDAR in their current state as of today, but bear in mind there are new kind of new features in this sector all the time. That's probably about 250 meters. Radar quite limited by fog generally. Everything on this diagram has its limitations, but LiDAR is probably the most effective when it comes to determining where objects are and what they are. Okay, so test vehicles. I've deliberately chosen this one because our company may or may not have been involved in some of the components on this vehicle. And you can see there all of the things I've just spoken about, but you can see effectively how they're placed on the vehicle and what they're doing. So you can see on the side of this vehicle, it's got mini LiDARs actually on the side of the vehicle, just behind the front wheels. You can see the radars at the front left and right corner. There's one in the middle as well in the grille. And there's radars at high level as well, just beside the LiDAR, and multiple cameras all over the vehicles capturing every side of it. We're going to probably the purpose of a test vehicle like this. Purpose of this vehicle is, number one, to test the systems, and number two, to evaluate the surroundings. So if you have test vehicles doing what effectively on a fleet of test vehicles, like fleets of this caliber, they're probably between 50 and 150 vehicles per fleet, per developer. So they'll equip all those vehicles and they'll set them out on the roads wherever it's permitted. And we'll get to some of the permissions later on. So they'll set them out and they'll set them analyzing the data. And the key objective for vehicles like this is to find situations that they have not seen before. So whether that's a HGV, whether it's a cardboard box in the middle of the road, because a lot of these systems, the cardboard box is the biggest nemesis to these systems. It will identify a metallic object, it'll identify a bicycle, stuff like that. But if you have a picture of a bicycle on cardboard and push it in front of this vehicle, it probably wouldn't recognize it. So that's kind of the limitations of some of the system. So it's just combining everything that you see on the vehicle into one version of the truth, one set of data for that, and to tell the vehicle that was a child on a bicycle, that was HGV, that was snow that you saw that day, all that kind of stuff. I was in Pittsburgh 2 weeks ago, and I might or might not have been with the people whose car this is. And Pittsburgh was -10. It was snowy as anything. And Pittsburgh is a kind of an underfunded city, if you like. And it was a steel capital back in the day, but of course it's trying to regenerate itself now into, being kind of a tech hub and whatever else. And therefore, Hyundai have an R&D facility there for these vehicles. But what the city of Pittsburgh had done is they sent their snow plows out, and and bear in mind the amount of snow that they had. You probably saw it on the news like 3 weeks ago. There had a lot of snow out there, and they just plowed it all onto the side of the road, and it was all on the right turn lanes. These cars hadn't seen snow of that magnitude before, and they hadn't seen lanes blocked by snow before. So the cars just kind of sat there and went, I don't know what to do because this is something new. It's a solid object, but what is it? I've never seen it before. So they had to basically train the vehicles to say, that's snow. That's what happens when the city of Pittsburgh sends their snow plows out, but only does the main lanes and leaves the right-hand lane blocked by this unknown object called snow. So that was a bit of a learning experience for the developers and for the car itself. Putting these things into mass production. So Hyundai in particular built a Robotaxi factory in Singapore, and they're building these things for whoever wants them. They're building for the Waymos, the Waves, and the Lifts, and whatever other customer. The idea being that all of these people have developed their own software and all that self-driving software, and they all have their apps and they all have their customer base, everything like that. If you've been to San Francisco, you'll have seen the Jaguar I-Paces from Waymo whizzing around. Well, they don't make Jaguar I-Paces anymore, so they're going to have to replace those cars with something. So Hyundai is poised to get into that market, not just with their existing known customers, but with every kind of robotaxi customer on the market. So yeah, they build a kind of a vanilla version of this with a standard set of radars, LiDAR, cameras, everything like that. And they allow the third parties to use them then as robotaxis. Getting on to robotaxis, I know some of you, well, I know some of you definitely seen them because we've talked about it earlier. Picture on the top left, Ford Mustang Mach-E, I believe, and that's doing the rounds in the streets of London at the moment with its LiDAR whizzing around on the roof and its cameras and its radars and whatever else. And allegedly, Wave is bringing self-driving vehicles to the streets of London. So you will see more and more of those. Are they a gimmick? Will they work? Will they recognize a bike lane? Will they recognize a curb? Will they recognize all of these kind of tighter streets of London that you don't see in Pittsburgh or Las Vegas or LA? Let's see. But chances are I believe testing is going pretty well there at the moment. Down on the bottom right there, the Waymo Jaguar I-Pace that I referred to earlier. These are everywhere in San Francisco at the moment. And yeah, it's a novelty. You'll see people calling them and you'll see people hopping in the back of them, and these things shoot off. They absolutely whiz through the streets and they find an empty lane and they put their indicators on and they will drive like they stole it. But it's the driver's seat is right up against the steering wheel, but there is a steering wheel there. There's just no driver there. So they are truly autonomous in that regard. So examples on the road. This is where I always come unstuck giving this talk, because invariably there'll be someone in a room who has a Tesla and they're on Tesla forums and they know everything about Tesla and they know everything about full self-driving, and Elon is a god and he wouldn't lie to me, he wouldn't dare, and everything like that, right? This is the version of the truth at the moment about self-driving vehicles that are on the road in 2026. So Tesla is a forerunner in the self-driving scene. It most definitely is. They have 3 versions of their self-driving technology. They have autopilot, which, as it says on the screen, is your adaptive cruise that I showed you earlier, the lane keep, and the blind spot assist and emergency braking as well. Enhanced autopilot, then, if you pay another little chunk of money, you get all of the above, plus lane change assist and auto park as well. So you get to your destination and it will park for you. And then full self-drive, or FSD, as the tech geeks call it, on every opportunity they get, gives you all of the above, plus it'll recognize a red light or a stop sign. So, you know, pretty much full self-driving, I guess, except for the SAE that I referred to earlier on. Because of the amount of incidents and ambiguity and everything like that, it's a bit like the urban legend of the Winnebago driver that got in the back to make himself a coffee because he was told cruise control would drive the vehicle itself. Well, which allegedly never happened, right? Every Tesla driver believes my car can drive itself. And I've seen them in action and they will get you from A to B, and it's pretty good. However, Tesla have had to introduce warnings to say, keep your eyes on the road at all times and keep your hands on the wheel at all times for all of these levels of driving. Because ultimately, Tesla will not bear the liability for anything that happens. So it is not truly full self-driving. The SAE has informed Tesla at the end of last year that all of these self-driving systems all sit within level 2. So nowhere near the level 5 that we referred to earlier on. They all sit level 2. Tesla put together a case to say, well, actually, they're level 4. And if I whiz back up just to that slide, you'll see what level 4 is. High automation. The vehicle performs all driving tasks under certain conditions. And the SAE argued and said, but it doesn't. It doesn't perform all the driving tasks under certain conditions. What are the certain conditions? A sunny day in California? What is it? And is it going to do all the driving? So Tesla had to back down a little bit. Tesla has, I'll get to what Tesla has done next in a second. But just to talk about someone else who does self-driving. So Mercedes-Benz in Las Vegas at CES in January launched their Drive Assist Pro. So Mercedes has had self-driving features or like very strong ADAS features for years. Mercedes-Benz, a leader in the technology field, brought out anti-lock braking, brought out airbags, lots of other innovations that have saved countless lives over the years. And Mercedes launched the new CLA in Vegas in January, and this was from the press release. 30 sensors, right? Sensors is just a global term for cameras, radar, lidar. So it's using 30 devices basically, including 12 ultrasonic sensors to determine where the car is, determine what's around it, and determine how it can drive safely. However, Mercedes have also reluctantly admitted that this still very much sits in level 2. It might be level 2.99 or 2.xx or 2 plus plus, but it's very much still in level 2. And all of the warning notices when you start the car up and you put it into any of this self-drive mode is that you are responsible as the driver. It's your eyes, your hands, your feet controlling that vehicle. So negative press, loads of it around. I could have filled a whole presentation on negative press surrounding autonomous vehicles. Biggest one for me is probably top left there. So both Mercedes and BMW have abandoned level 3 automated driving. So a couple of years ago, when Mercedes launched the current S-Class, they were the very first ones to say we've reached level 3 driving. So level 3, a couple of slides, I should have put intermediate slides in here. Level 3, conditional automation. The vehicle can control most driving tasks. And it could. On an autobahn, up to 60 kilometers per hour, it could drive. So heavy traffic, if anyone's ever driven in Germany or the Netherlands or the M25, at certain times of the day, it's pretty slow traffic. And if you're driving yourself, you'd be like, I'm so bored, I'm so distracted or whatever. Great, let the car drive for you. And it will. It was genuine level 3 up to those speeds. It cost approximately €10,000 as an optional extra to have self-driving. And it was only available on the S-Class. BMW brought it in shortly afterwards on the 7 Series. These are cars that cost, what does anyone spend on an S-Class? I don't know, 100,000, up to 150,000, maybe more. It's generally not them driving if they've spent that much money on a car. It's generally somebody else driving. They've already got autonomous driving. They're already sitting in the back distracted because they're paying someone to sit up front and do the driving for them. So this 10 grand option was an option that very, very few people took because it was so limited in its use. It's not going to get you down the autobahn at 120 miles per hour. It was for traffic jams to drive itself. And if you're sitting in the back in one of these cars, generally, you've got a driver to do it for you. Second headline there ties into what I said about Tesla and their constant battles with the authorities on what they can and can't say. So Tesla were told that they could not use the term autopilot for their vehicles because autopilot infers you're hitting a switch and you're letting the car drive itself because Elon said it was level 4 or level 5. It's fully autonomous, my self-driving car. Whereas they were told very bluntly, it's not, it's still sitting within level 2. You're going to have to warn people to keep their hands and their eyes on the road. And you can't call it autopilot. So Tesla is now suing somebody, as they do, about the fact that they were not allowed to advertise it as autopilot anymore. So there we go. Just talking about legalities. There's been a few changes to the law to allow autonomous driving. So in the UK here, Autonomous Vehicle Act 2024. Ireland, the Road Traffic and Roads Act 2023 was introduced to address the allowability of test vehicles or vehicles to be autonomously driven for test purposes. And then USA, which and I know there's a lot of other places as well, but I didn't want to get into every country globally that allows it. But there's only 7 states that allow driverless vehicles, and of course it's your Nevadas, Californias, places like that, that are nice, big, wide open spaces and grid-like streets, everything like that, everything nice and simple. So 35 states have addressed autonomous vehicles legally, but the remainder have just ignored the issue. And they ignore the issue because it's a non-issue for them. Your Alaska or your Hawaii or whatever else, who generally cares if there's autonomous vehicles there or not. They're saying, we'll worry about it if we see any here. But they've just ignored the issue for now. Speaking about the Ireland one, I saw Don Smirk a couple of minutes ago. There was a case in the papers probably 2 years ago now, I would say, of a chap that was pulled over by the guards on the M50 in Dublin because he was driving his car much in the position I'm in at the moment. He had a Tesla Model 3 and he was sitting there with his arms folded, and the police pulled up alongside him and looked in and said, what's he doing, steering with his knees, or what's he doing? He's not paying attention. So they pulled him over, and he argued his case that the car drove itself. And the guard said, well, no, it's your car. It's up to you to pay attention driving. So he ended up in court. He had a day out in court over it. And basically, the whole ambiguity about whether or not the car could drive itself, the judge just said, well, it probably can, and dismissed the case, leaving the guard somewhat red-faced. Now, I think it was Don originally sent me a link to the story about this chap, and yeah, he's one of my colleagues in Dublin who was up in court that day. So and he would be the kind to try out self-driving. So yeah, that's quite a notorious one in our office, let's say. So yeah, just to kind of summarize, I don't know how we're doing time-wise, Don, but probably thereabouts. I guess, the one message that came out of my most recent visit to Pittsburgh with the development that was going on there is that robotaxis in themselves, I don't really want to use the word gimmick. However, robotaxis have been used out there to trial lots of these systems for autonomous driving. The robotaxis are used to collect data, to collect everything about weather, about the car itself, about the performance of the car, about getting people to and from the airport in maybe a slightly, a novelty way, if you like. But it's something that people would talk about afterwards. I was in a driverless car in San Francisco where, I did this, I did that, and I got my cases in the boot as well. But what these are being used for is to roll down that technology to your everyday cars in the coming years. Actually, it's in the very near future. So cars will be equipped. Unfortunately, we've all seen it, all of our cars, those that have cars here, they're all equipped with more and more technology, which I think is great. And then some of it's a little bit overbearing, like the constant beeping when you go over a white line or whatever. It's probably, if you consider that annoying, it's probably going to get worse. So cars, they're going to have more technology, but it is ultimately going to lead to safer vehicles on the roads. And that's pretty much the whole objective of these development things. None of this development is cheap. The cars are the cheapest component when you look at robotaxis or test mills. Everything else that goes on top is exponentially more than a car. So, a LiDAR can cost you, 10, 15,000 on its own. The radars, the compute platforms, the storage involved for all the data, analyzing the data afterwards, improving the self-drive algorithm, everything like that. It's a very kind of a circular process, but it all goes into refining how self-driving will work eventually, or how the step to level 3, 4, and maybe one day level 5 will be reached. So, as I said earlier, current SAE level, it's very much still sitting in level 2. Guess one thing that I forgot to mention earlier on was that if you're in level 3, 4, 5 and the vehicle's driving itself, and if it had an accident, who's culpable? Mercedes basically said they would cover um, damage to any of their self-driving vehicles if it was being driven in self-driving mode. And that's a fairly big, that's a fairly big admission of liability there for anything that goes wrong. But of course, they can examine the fact afterwards, a bit like having a dash cam, but having a whole computer full of sensors, and you can replay exactly what happened and how it happened. And Mercedes were confident in their system, and they said, "Well, yeah, we'll hold full liability for this, but we don't care because it's not going to cost us anything." And I'm not aware that any of their self-driving vehicles were involved in accidents anyway. Um, Level 3 implementation was premature, which is a statement there. There was a big song and dance by Mercedes about having the first true Level 3 vehicle, very conditional Level 3 vehicle, but they were very proud of it. They've dropped it. It's just untenable. It was an accessory that people just didn't want. And then, so the last statement there, we all know it. We've all seen computers and processing power increase exponentially over the years. So does the cost. Um, there are pinch points in the industry about component availability that determines development, everything like that. But in general, the capability of radars, of lidar systems, everything like that. A new one comes to the market every year that's super duper and exponentially better than the previous one. Implement that on a vehicle, self-driving improves, and repeat. So the whole lot basically goes in cycles, as it were. But the solutions are getting better. And yeah, level 3 and beyond are most definitely still the aspiration. But for now, still very much in level 2, and it's your own insurance every time, I'm afraid. Okay, thanks for listening. I'd welcome questions. Don, I know you're the Q&A master. And any questions here in the room, first of all, before we get to any online ones?
What would you say is the biggest obstacle getting beyond level 2?
Industry acceptance, or acceptance by bodies like the SAE to prove your case that it is actually beyond level 2. Mercedes did it with level 3, but the technology was just prohibitively expensive to get to that conditional level. So cost, I would say cost at this time. I'm certain the capability is out there, but it's going to turn a 50,000 Hyundai Ioniq 5 into a 150 or a 200,000 conditional self-driving vehicle. So it just doesn't warrant itself. Yeah, I guess you will see more radar and lidar being introduced on vehicles to make things like adaptive cruise control, maybe with overtaking functions or whatever else, more feasible. Components like that are, components like radar, ultrasonic stuff like that is more feasible to integrate on an everyday car. But yeah, some of the biggies to make it truly autonomous, they're just still prohibitively expensive. Okay.
Yeah. When did the industry expect that the average Joe can actually go and buy a fully level 5 autonomous vehicle themselves?
Very much moving feast. If you go back to press releases in 2018, they were saying 2025 there'll be self-driving cars. I know we had a slight blip of a pandemic in the middle, and then there was component shortages, stuff like this, which slowed down things. But I think it's the whole, it's the market demand and the kind of the public perception of full self-driving that, if you're going to go and buy a car and it's full self-driving, then, well, you can take a taxi or use a Robotaxi, one of the ones that's driving around London at the moment, for example, or that would, that will be in action from Wave very shortly. But for it to be your personal vehicle and for it to drive itself, I would say that market is very much in its infancy.
Pat has asked how the technology will get over the fact that actually there are huge variances in the quality of the asset that the car is moving on, and the features that it would be able to recognize, such as curbs or fences, signs, all that kind of thing, which vary by types of road and by geography?
Yeah, no, it's a great question, Pat. I guess it goes back to the learning cycle of test fleets. So if you've got a test car going out and it recognizes the lack of a white line or recognizes traffic cones one day that weren't there the previous day, but it has seen in certain circumstances and knows how to react to it, or lanes merging. That's probably send an autonomous car down the A303. How far is it actually going to get? Because of it's two lanes, it's one lane. There's roadworks, there's traffic lights, everything like that. So it's all about the learning cycle and learning development there. So basically, using not every car, but using a sample of vehicles that have a bit more hardware on them than the average, to use them to go out and be the data collectors. That data then gets analyzed, uploaded, analyzed. It goes through a cycle called hardware in the loop, software in the loop. The self-driving algorithms get refined then to say, well, now you recognize what a merging lane looks like, or a traffic cone, or snow in Pittsburgh, or whatever it's going to be, and deal with it. And then that vehicle now has the ability to recognize kind of unique situations. And there are unique situations in every country, like with regard to, say, traffic light sequencing or pedestrian crossing, if there's somebody standing there, and what the rights are if it's a pelican crossing or whatever it is, and what to do in that scenario. But it's the recognition of them that is going through this constantly improving cycle. Yeah, very much so. Can an autonomous vehicle recognize a pothole? I mean, we all certainly can at the moment, right? But yeah, exactly. And that's going to be more prevalent in areas with extreme weathers, like say the UK, where it'll go from freezing to heat. But where you have say more constant temperatures and lots of daylight and smooth, billiard table tarmac roads, development and implementation of these vehicles is easy. But that's part of the challenge about getting autonomous fleets up and running in the narrow lanes of the Ring of Kerry or down the A303 or whatever it happens to be.
I have two questions waiting in the room, but I've got two questions online, so I'll go to one of those first and then I'll flip over back. So D. Murphy has asked, thank you for the lecture. Who bears responsibility in incidents? It's in brackets, operators, manufacturers, or software providers. Where are insurers likely to fall on this issue for driverless systems?
That's an excellent question. There's a fine line down the middle between level 2 and level 3. And I guess anything left, if I just maybe pop back to that slide, anything left of level 2, so level 0, 1, and 2, insurance and liability goes the way it's always gone. You're in control. Level 3, 4, and 5, when a vehicle is running in autonomous mode, it's generally the manufacturer of that vehicle, so the person from whom you have bought the ability for the vehicle to drive itself, whether it's a feature or whatever, they bear the liability in that instance. So whether it's Tesla, Mercedes, BMW, whoever's left on the market doing self-driving, they bear the liability. But bear in mind, if you've got a self-driving Mercedes and you're doing 100 kilometers per hour in it and have an accident, you can't really say that it was self-driving at 60 kilometers an hour on an autobahn in the exact situation that the self-driving has been, conditionally applied to. If you're outside the conditions set by the manufacturer, then it's you that's liable.
Thank you. I've got a question here.
Yeah, I was just thinking about public transport, and all of this very advanced technology would be much easier applied to, say, trams or trains and maybe even buses.
Yeah.
Is there any momentum in that component of the market?
So the question for those online is whether there's any momentum in the public transport market for buses, trams, trains, those kinds of vehicles.
I can deal with trains. It's kind of my specialist subject anyway, so that's an easier one to answer. Trains very much have a line side signaling system, and that controls that controls where the train can be and how close it can be to the train in front or whatever. And there's lots of safety margins there. That said, it kind of harks back to Victorian times. There was things called a block, and a train can be in that section. It can be in that signal block, and nothing can be in the block behind it. And then a train can be in the block behind that. We've all stood on platforms and we've seen the single yellows, double yellows, greens, whatever. And, you know, it's just basically it's phases to say how clear the line ahead is and what the driver should do. There, for anyone that's been on Thameslink through what's called the core, so between, say, Kentish Town and Blackfriars, those trains run autonomously in that section. And basically, the driver goes hands off at Kentish Town and he puts his hands back on as the train leaves City Thameslink. And that's controlled. It's controlled again by line side signaling. It's controlled by beacons that are in the middle of the track that sensors on the train picks up. It knows the speed of the train. It knows exactly where the train is. And it knows where the train in front is and the train behind is. And it'll coordinate them all so that they all move nicely in parallel. So quite often, if you are stopped at, say, the tunnel into St. Pancras Station, and you know there's a train ahead of you, but you can virtually see the train ahead of you because that's how that automated system works. It works on a different basis to autonomous driving because obviously it doesn't have to worry about blind spots or overtaking or continuous white lines or anything like that. But it's kind of a similar principle to the adaptive cruise control. It can stay a set distance from the train behind it. I think the only thing that the driver does on that train is to push the close door button in that area. The doors open by themselves, but only the driver can push the close door button. That's determined to be an automatic factor. Trams and buses, sorry for the long-winded answer here. Trams and buses, are using very, very similar technology, if not identical. This is, it's one of the major deployments. Driver fatigue in that area can be catastrophic. I know driver fatigue anywhere can be catastrophic, but if a driver has 70 passengers on a coach and for whatever reason it goes wrong, then it does have certain safety systems now, pretty much exactly like your everyday run-of-the-mill car. But certainly levels of autonomous driving to introduce them they are being brought in and will help things. Trams, it depends on where. Lots of trams drive on site anyway. They'll have fundamental signals like traffic lights to get them away from the junction, but things like speed, things like distance, they can stay behind them. If you've ever been to Cologne and say seen the streetcars or trams there, they're virtually one on top of the other. They come very, very hard and fast. They drive on site. Not aware of any autonomous systems being introduced on them. And it's heavily unionized as well. So, you know, bringing something else in to do the job for them, not happening. Yeah, I hope that answered the question.
Thank you, Brendan, for bringing industrial relations into it. I'm going to go to an online question. Munya Machora has asked, are these vehicles programmed to communicate with CITS infrastructure? The V2X technology is a growing space, and it seems like AVs are leaving this out completely.
I would agree. They're leaving it out, whether that's completely or not. I don't know. All of these vehicles have a degree of connectivity on board. I was kind of surprised by the degree of connectivity they have on board. I expected that at least the test cars would talk to each other and be able to navigate their way around each other. If you've seen the Motional garage in Las Vegas, is a pretty big space and cars driving into it autonomously. The same in the Waymo parking lot in San Francisco. There's a few videos doing the round of all the cars beeping at each other all night, every night, because they're all getting in each other's way, and these cars aren't talking to each other. They're alerting. It's one car alerting the other that there's a car there, but doesn't realize that it's his buddy. And if they only talk to each other, they could figure it all out. But yeah, I'd have to fully agree. They're very much being developed as at this time as something that acts in isolation. And it can be full. Sure, I know Germany did it with stretch of Autobahn, I believe, from Nuremberg to Munich. It goes past the Audi factory in Ingolstadt, and they lined a section of that with LiDARs, radar, everything like that. Similar. Dara mentioned smart motorways in this country, but it was slightly different because a lot of the vehicles, they had test vehicles that would use the line side beacons for to effectively register themselves on that stretch of motorway as well. Of course, the general public feared it was just an excuse for taxation and that, there'd be tolling and everyone's number plate would be recorded, and German privacy laws being what they are, they weren't very happy about that. But it was more about, having it as a three-dimensional live scenario where the vehicles were talking to each other and they were talking to roadside. So every vehicle was supposed to know where everyone else was at the same time. It was quite a successful scheme, but expensive for what it was, and it never went any further than the few mile section of the A8, as far as I'm aware. So again, I hope that answers the question.
Thank you. Con, you had a question?
Yeah, I was just wondering from reporting accidents, what are the general problems they're facing at the moment, say, for level 3?
Reporting accidents, that's a great one. There's there's a website that the Californian DMV use, and it's in public access. You can click on it and it says accidents involving autonomous vehicles, and you will see all of the above listed there, and they all have a legal obligation under the self-driving laws in that area to report all their accidents. These accidents are filled out generally on a paper form, and they're handwritten, and they're put in by whomever analyze the accident afterwards. The vehicles do not. The vehicles generate an emergency alert, and it'll alert the police. Of course, the police in the US show up for any particular reason anyway. But it's fascinating reading of these accidents. But it's very much it's a manual process. They're kind of vetted by a human, as it were, and then they're included. But they're a fascinating read if you've got a glass of red wine and a few hours one evening just to sit down and entertain yourself. They're fascinating. Very few fatal accidents, I have to say. Very, very few. Cyclists, right? Cyclists. It's the kind of the cyclist that appears out of nowhere in his Lycra, and he's getting his best Strava time and is commuting to work that morning, and the cyclist doesn't see the autonomous vehicle. Whether the autonomous vehicle has time to react to the cyclist that's come around the back of something else and is shot down the inside and got knocked off, who knows? That's generally it. There's a few other cases where third parties have just driven into the autonomous vehicle. I thought it would stop, even though they've kind of T-boned it, to use an American phrase. Yeah, so accidents, I have to say, luckily they're rare. They will report themselves to the authorities and they'll stop in a stationary way. I believe, and I hate to bring this up as an example, I believe there was somebody dragged under a Waymo in California maybe a year ago, 18 months ago, which the car just didn't realize that there was someone under it because it hadn't seen or taken note of the fact that this person had entered the scene at all. So it caused Waymo to be suspended for a little while in San Fran, and yeah, I believe the person survived, but it was a bit of a harrowing ordeal. And it's very hard to stop one of these cars if they're going, as the person that was stuck in the back of one going around a car park and not getting out of it. I don't know if you've seen that example. Yeah, they were stuck in a Waymo going to the airport, and they said, I'm probably going to miss my flight because we just keep doing loops. The car could not find the exit. It's a bit like Heathrow long park and ride parking as well. I struggled to find the exit on that. So I can't blame the Waymo for that one. But yeah, I hope that answers that for you. Right.
Thank you. We've got another online question from Michael Goggin. Very interesting presentation. Thank you. This technology is always developing and getting better, but not necessarily massive leaps every year. To your point that this tech cost can dwarf the base cost of the car at times, is this likely to change how vehicles depreciate in the first 12 to 18 months after purchase? I don't know whether Michael is in the market for a car. Brendan, your answer to that?
Well, he's driven off the forecourt and he's lost 30% of the value anyway. Isn't that the old adage?
Yeah.
No, it's a good one. So I guess year on year, Michael's quite correct. We don't see that many changes in new technology. What you have to think about is the life cycle of a current car is probably 6 or 7 years. That every 6 or 7 years, maybe 8 years, right? Let's call it 8 years. Every 8 years, manufacturer will bring out a new model. And it's those, well, and every 4 years, say, they'll have what's called a midlife cycle kind of refresh of the car as well, a facelift, if you want to call it that, or they'll introduce, new lights and new colors, and they'll pretty much do the upsell. But generally, it's the introduction of a new model every 6, 7, 8 years, depending on the manufacturer, that will see the biggest increases. So things like adaptive cruise control, I think Volkswagen brought that on the Golf probably about 2013, 2014, virtually became a standard feature. Everyone was saying, right, I'm going to have adaptive cruise control as standard on my car whenever they bring out the next one. And not the case. Most manufacturers will offer it to you, but they'll still have it as an optional extra there for a few £100. So yeah, it's with every new model you see the increases, and that's where you can expect to see the latest, safety. But of course, it'll get buried in a shiny motor show where they release, and it's probably nowadays, what's the biggest motor shows? Probably Beijing, even Geneva, which I think is every 2 years at the moment, or Frankfurt, one of them, and that's where you'll see the kind of the newest features, newest safety features, newest levels of autonomy being brought in. But yeah, it certainly won't be year on year. So again, I hope that answers.
Thank you. I have another online question from Munya Matura again. Is there any work required for roads authorities to upgrade lane markings and road signs? And points out that signs in Ireland are different to those in the UK, brackets Vienna Convention.
It's very true. In road condition, I alluded to that one earlier on, that in the current climate, certainly in the UK, I personally think Irish roads are better than in the UK at the moment, but topical point. Yeah, local authorities have a complete backlog of improvements to do with lane marking, stuff like that. I don't know if any of you who have driven on a motorway, say the M25, after a period of roadworks is finished, and you drive there at certain times of the day or night or whatever, and you'll struggle to see where the actual white line is, because there's a white line or a yellow line or whatever that's been painted over adjacent to it. And you're thinking, well, if I'm struggling, how's an autonomous vehicle going to figure this out? And the answer is, with multiple cameras placed at strategic positions, these cameras don't really suffer from glare like you maybe would as a driver with oncoming vehicles. Cameras can filter out a lot of oncoming lights, and they can actually analyze where the correct white line is and where to adhere to it. That's probably the biggest one. Road signs are, I guess, less importance. Things like destinations, or how far away Cork is, or stuff like this, kind of driver information that's just kind of nice to have. Those signs don't matter. What matters is overhead gantries, changing speed limits, that kind of stuff. Lane merging, stop signs, all that kind of stuff. Yep, there are lots of differences, and there's different languages, everything like that. The idea is that before level 3 or above, that vehicles are correctly calibrated for the markets in which they're being used. In Europe, there's a general convention there. In the US, there's a general convention as well. So your speed limit signs will be round. No entry signs differ from country to country, as we know. Road markings about what lane to be in for left turn only, that kind of stuff. There's another kind of a legal argument there that says road marking isn't, strictly speaking, legally binding. It's the signage that goes with it that makes it a legal requirement. So if you see a left turn lane, do you have to turn left there? You think so? If it's a road marking only, allegedly not. If it's a sign up there that says this lane left, this lane straight ahead, then it's legally enforceable. And that's another kind of a can of worms I've potentially opened there as well. But it's all about having developed a product that's suitable for the market in which it's being sold. I guess that's the bottom line.
Thank you. Any question in the room?
the robotaxis that speed around San Francisco,
Mm.
what level of autonomous driving would they be? And what are the frequency of accidents like that? Would it be greater than most other vehicles?
I mean, there's an argument for people to say that, well, they're level 5, they're fully autonomous. Nobody controls them. They just do their own thing. I guess, you know, the where they go is going to be determined by the position of the person that calls them on the app and where they're going to. In the same way as you use Uber now, these autonomous cars work in the same way. It'll show up at your destination. You get in and it drives itself and off it goes. Personally, my feeling is that they would be in level 4. They would be they'd be kind of highly autonomous, if you like. That, you know, they're not fully autonomous in all weathers. If you threw a freak snowstorm at San Francisco or -10 or whatever, could these cars still function correctly every time? Are they truly level 5 under all conditions, as the text says? And you could very quickly argue, well, no, they're they're not level 5. They're probably very comfortably a level 4. And put a traffic cone on the bonnet of a Waymo if you want to see, because that confuses the hell out of them, and they just stop and put their hazard lights on and don't go anywhere. As part of the sabotage against Waymo in San Francisco went, actually. So.
Thank you. We have one more online question. So this is from D. Murphy. Does the connectivity of autonomous vehicles create a credible risk of fleet-scale remote disablement or accidents during a potential cyber attack?
Could you repeat the first part of the question?
Yeah.
Sorry.
Does the connectivity of autonomous vehicles create a credible risk of fleet-scale remote disablement or accidents during any potential cyber attack?
Yeah. You'd have to say yes, everything's vulnerable. The manufacturers of these vehicles will employ the best cybersecurity that they can. Obviously, there is a kill switch, if you like, in the central command that they can, there's a panic button in the car. I've sat in the back of them. There's a panic button there, and the panic button doesn't stop the car. That panic button puts you through to an operator that says, "What's your problem?" A little bit like being stuck in a lift. And that the operator said, you tell the operator your concerns, and they'll go, "Okay, I'm going to disable the car, and I'm going to send a driver out to take over, or I'm going to reset things, and we'll see how we go." It does happen. Could a cyber attack affect that connectivity? Yeah, undoubtedly. It's cellular technology ultimately that they've got connecting the operator to the vehicle. So yeah, it could undoubtedly happen. It hasn't yet.
Yeah, interesting. Any other questions in the room? And we don't have any further questions online. Brendan, thank you. I think I'll wrap up. Look, this is, as you said, a follow-up from 5 years ago. Thank you for coming back and updating us.
Thank you for having me.
6 levels from 0 to 5 inclusive. It's great that it doesn't start with 1, it starts with 0. You took us through sensor technology and the testing methodologies and the contentions around what levels car makers can ascribe to their products at the moment. But what was interesting was, for me, the development objective through all of this testing and all of this development right now is about improving safety. And I guess the way to monetize that is the Robotaxi, given the inordinate scale of additional cost that sits there. Yeah. We got into insurance in the questions and answers. We got into actually how do we deal with the parlous state of our roads. We got into a comparison of UK and Irish roads and their parlous states. But I think, and we also got into the last point was that the risk of cyber attack. So, Brendan, thank you very much for taking us through that. A bunch of engineers, many of us in the room, civil engineers, but we all really like cars eventually. So thank you very much for taking us through that. And could I ask, please, our audience to thank our engineers?